In 2026, we've handed AI the keys to our most sensitive databases. But what if a single, harmless-looking smiley face emoji could bring the whole system down? 2-sec silence. Welcome to this deep dive. I'm really glad you could join us today.
It's great to be here. We have some incredibly fascinating material to cover.
We really do. Our source material today is Max Ann's March 2026 AI Security Guide. It's an extensive look at modern pen testing and defense strategies.
Right. It basically maps out the completely untamed Wild West of 2026 AI security.
And Wild West is honestly the perfect term for it.
Yeah, it really is.
We're going to uncover why prompt injection is essentially the new SQL injection. We'll examine the massive vulnerabilities hiding inside overprivileged AI agents.
We'll see how autonomous AI hackers are, currently winning bug bounties.
Let's start by unpacking this massive adoption gap we're seeing. The guide highlights a staggering statistic right up front.
Yeah, that 72% number.
Exactly. About 72% of enterprises currently use AI agents in their daily workflows, but only 29% actually have AI-specific security in place.
It's a genuinely terrifying gap. I mean, the vast majority of companies are flying completely blind right now.
Developers are under immense pressure. They have to ship code quickly.
Right. They have to meet market demands.
So they're largely ignoring the underlying security implications.
They just bolt an AI onto their database.
Yeah, call it a day.
Exactly. It feels exactly like the early web era with SQL injections.
Back then, people were building dynamic websites incredibly fast.
But they were leaving massive database backdoors wide open.
And that exact same historical moment is repeating itself today.
Except today, the primary target isn't just a static database.
Right. It's the automated decision-making AI system itself.
Jason Haddix from Arcanum Information Security makes a brilliant point about this.
He states that AI pen testing is the most critical skill of 2026.
Right. And he makes a really important distinction there. People constantly mix up AI, red teaming, with actual AI pen testing.
Red teaming is what we always hear about in the news.
Yeah, exactly.
Yeah.
That involves attacking the model itself. You try to force a bad output or make the chatbot say bad words.
We're checking the brain of the AI system.
Right. Those jailbreaks definitely still matter for brand reputation. But red teaming only tests one single isolated layer.
True AI pen testing is a holistic assessment.
Yes. It checks the APIs, the pipelines, the infrastructure.
So if red teaming checks the brain, pen testing checks the whole body.
That analogy is spot on. The brain is just the language model generating text. The body includes the network of APIs fetching external data. It includes the cloud storage buckets holding private company documents.
If you only test the brain, you're missing 90% of the actual risk.
Exactly.
Why do so many companies only bother testing the brain?
Mostly because the brain is the public-facing part. PR disasters from bad outputs are immediate. They're embarrassing. Companies rush to prevent the AI from saying offensive things. They completely forget that the silent background data pipes hold the real value.
Attackers don't care if your AI uses bad words.
They care about the private customer data flowing through its back-end connections.
So they secure the chatbot but leave the back door wide open.
Right. And that brings us directly to the rapidly expanding attack surface.
Most people think AI security just means tricking a text box.
But a real, production-ready AI system has 6 distinct layers of vulnerability.
First, you have the underlying model itself, including the system prompts.
Right. That's the foundational layer. Next, you have the API connections and internal webhooks.
Then you have the data aggregators running quietly in the background.
Meaning your private databases and your complex RG pipelines.
Then we hit the critical integrations layer, like Zapier connections or your internal CRM.
You also have the actual application sitting directly on top.
The web or mobile interface.
Exactly. And finally, the foundational cloud infrastructure layer.
I still wrestle with trusting basic API integrations myself.
Yeah.
Beat. It always feels like you're leaving a digital window unlocked.
You are absolutely right to feel a little paranoid about that.
Yeah.
The source guide shares a brilliant real-world warning sign about this.
This was the company that rushed an internal AI assistant into production, right?
Yeah. They just wanted to help their sales team draft emails faster. They didn't consult their security team at all.
And months later, they discovered a massive silent data leak.
It was devastating. The AI assistant had been quietly sending sensitive sales data out.
Directly to third-party AI providers.
Right. Storing it on external servers. Nobody meant for it to happen.
It happened because security wasn't involved during the integrations phase.
Exactly. This is why professional AI pen testers follow a strict 7-step methodology. They move through the attack surface logically.
Like a burglar checking every single entry point.
Right. Step 1 involves testing the basic external system inputs.
Step 2 maps out the entire connected digital ecosystem.
Step 3 is finally attacking the actual AI model itself.
Step 4 focuses heavily on advanced prompt engineering.
Step 5 targets the underlying data layer and vector stores.
Step 6 is exploiting the application front end.
And Step 7 is pivoting to move laterally across the network.
What actually happens when attackers decide to skip the model entirely?
They look for weaknesses in the surrounding infrastructure instead. They might find an unsecured API endpoint that the AI uses. They send commands directly to that endpoint, completely ignoring the language model.
They bypass the AI entirely and just exploit the connected data pipes.
Precisely. And this brings us to the biggest threat of all.
Prompt injection.
It is essentially the new SQL injection of our era.
It's the defining vulnerability right now.
Attackers hide malicious instructions inside natural language inputs.
The AI processes these hidden instructions as completely normal input.
Exactly. There are 4 distinct attack primitives we need to understand here. Think of them like stacking Lego blocks of data.
First, you have the actual intent of the attack.
Right. The intent could be extracting highly sensitive private emails. Second, you have the specific delivery technique.
Disguising the attack as a harmless role-playing scenario.
Yep. Third, you have evasion techniques to bypass standard safety filters.
Like using complex encoding or obscure foreign languages.
And finally, you have the specific utility add-ons, small additions designed to bypass system guardrails.
When you combine these 4 Lego blocks, you get incredibly complex attack paths.
This is where it gets really wild. Attackers are using something called emoji smuggling.
This one is so clever. Computers don't actually read emojis as little pictures.
No, they read the underlying Unicode characters.
So an attacker encodes malicious textual instructions inside the Unicode metadata of an emoji.
They hide a command to delete files inside a harmless smiley face.
The human user just sees a normal smiley face.
But the AI reads the encoded text data and follows the malicious instructions.
They're also using link smuggling.
Right. Crafting deceptive URLs that steal conversation data when clicked.
But the most dangerous risk of 2026 is indirect injection via retrieval.
Yes. That's when an attacker poisons a document inside a database.
Or a web page the internal agent will eventually read.
The attacker doesn't even interact with the AI directly. They just plant a booby-trapped resume in an HR database.
Why is this indirect injection considered such a devastating threat?
Because it operates completely silently. You poison one document, and it waits patiently for months. When the AI eventually pulls it, it gets hijacked mid-execution.
One poison file sits in memory and infects every future query.
Exactly. This is why beginners desperately need safe places to practice.
You have to start practicing offensive AI security to build real intuition.
The guide recommends a very specific practice progression. Step 1 is Gandalf by Lecara.
That focuses on teaching basic prompt manipulation, right?
Yeah, learning how these models behave under persistent pressure.
Then you step up to Agent Breaker.
Right. This dramatically raises the overall difficulty. You're facing multi-step AI agents that have memory and actual tools.
Why does practicing on these multi-step agents completely change the game?
Single-turn chatbots just reply with text. Multi-step agents actually browse the web, read documents, and call APIs. You have to understand how each separate step connects.
Agents take actual actions, meaning you can hijack them mid-task.
You nailed it. And that leads to the final practice stage.
The AutoPart CTF.
The pro-level, self-hosted capture of the flag. It's built from a real client pen testing engagement.
It features deep business logic flaws and actual data exfiltration paths.
It perfectly highlights the next massive vulnerability we must discuss, the MCP Security blind spot.
Let's define MCP plainly. It's the digital bridge connecting AI agents to real-world tools.
Exactly. It connects the AI to databases, emails, and CRM platforms.
It turns a chatbot into a worker.
But it introduces a massive security gap. There is no standard role-based access control right now.
The default is giving the AI far more access than needed.
Right.
Why do developers give AI full write access initially during setup?
Developers are under immense pressure to ship incredibly fast. Configuring granular read-only permissions takes time and testing. Giving full access just works immediately.
It's just faster to grant full access than configure strict rules.
Unfortunately, yes. And this creates a truly catastrophic attack chain.
It starts with a simple prompt injection attack.
Which leads directly to a compromised internal AI agent.
That compromised agent uses its overprivileged MCP connection to wreak havoc.
Suddenly, the attacker has full write access to highly sensitive medical data.
Or secure financial records.
This is why the golden rule of 2026 is zero trust. Never give an AI agent more access than it absolutely needs. Mid-roll sponsor read inserted here, do not pull from newsletter text.
We need to talk about AI hacking itself.
Yeah, something important is happening right now, and it's making people very uneasy.
Autonomous AI tools are actively competing in human bug bounty programs.
And they aren't just participating, they're winning them.
Against top-tier human hackers.
Tools like XBOW and Aracne are topping the global leaderboards today. They're finding real, complex flaws remarkably fast.
Whoa, imagine an automated AI hacker scaling to 1 billion queries a second against unsecured networks. Beat.
It is genuinely a terrifying thought. The sheer speed of these tools is unprecedented. Automation is coming for routine pen testing first.
Automated vulnerability scanning is already standard.
This creates a truly chilling gap for many organizations. Companies with zero security testing are severely exposed.
They're about to face attackers wielding automated AI tools.
The baseline level of offensive capability is rising incredibly fast.
What happens to human security experts now that AI automates this?
Routine vulnerability scanning is going to be handed over to AI. It's just faster. Human experts will need to focus on understanding complex business contexts.
Humans move to complex judgment calls while AI handles the routine scanning.
That is the rapidly approaching future of the security industry.
So what does this all mean for us moving forward? We're seeing a massive shift from chatbots to active workers.
AI security is no longer about preventing offensive generated language.
It's entirely about preventing unauthorized action execution.
You are defending the tools, the databases, and the infrastructure.
The primary focus must be on zero trust principles for all AI agents.
You absolutely need strict access control at the MCP integration layer.
You need to thoroughly audit your integrations right now.
Assume prompts will eventually be extracted by clever attackers and run a real pen test before users ever touch the product.
Before we wrap up, I want to leave you with a final provocative thought.
Let's hear it.
If AI agents like XBOW and Aracne are autonomously finding zero-day vulnerabilities faster than humans, how long until we have to rely entirely on AI to write the defensive patches?
Wow.
And if an AI is writing the patch to defend against an AI attacker, who is really in control of the security ecosystem?
That is a fascinating question to leave off on.
Thank you so much for joining us on this deep dive. We will catch you next time. Out to your own music.